Okay, so in this video I'm going to look at using trigonometric identities, and I'm going to do this. I'm going to do a number of examples. Now, in previous videos I looked at deriving 8 of the trig identities, so there are other ones that you can use as well, but we're going to look at using some of these to do some questions that you may be asked. So the first one is write the following in surd form. So we're going to write tan 75 in surd form. So that's the question we're asked to do. Now, usually when you see a question like this, you should immediately think about these angles here, these special angles, 30 degrees, 60 degrees, 45 degrees, because we know all of these, sine, cos and tan of these in surd form. So if we look at tan 75, it's not one of these angles, but what we do is we make it 45 degrees plus 30. 45 plus 30 will give me 75 degrees. So these are the same here. And these two angles are these special angles. Now, the trig identity that we can use here, this is really tan of A plus B. And we know from previous videos that the tan of A plus B is equal to tan A plus tan B over 1 minus tan A times tan B. So let's just do that here. Well, this would be tan, that's just the same as tan A, which is 45 degrees, plus tan B, which is tan 30. All over 1 minus tan A, which is tan 45, multiplied by tan 30. So this we can do easily enough. So tan of 45 is just 1, plus the tan of 30 degrees, the tan of 30 degrees is 1 over root 3. On the bottom we have 1 minus tan of 45 degrees, again, is 1. We got to multiply that by the tan of 30 degrees. Again, the tan of 30 degrees is 1 over root 3. Okay, so we can do this. I'll just move over here. If we add these two on the top, we get, let's see, root 3 is our common denominator. This is 1 over 1. So we get root 3 plus 1. On the bottom here, again, our common denominator here, if you like, is root 3. So this is 1 over 1 here. So this time we get root 3 minus 1. And you can see if you flip this upside down, multiply, the root 3's will cancel, if you like, or divide. And we end up with root 3 plus 1 over root 3 minus 1. So that's our answer to the first one, tan of 75 degrees. Let's have a look at another one. Let's have a look at the sine. This is number 2 here. So we look at the sine of 105 degrees. So the sine of 105 degrees, okay, so we need to try and make this into the sine of two of these special angles. So let's take the sine of, let's see, 105, it's probably going to be 90, no, let's say 60, I think it is, 60, isn't it? Plus 45, that'll give me 105, yes. So we have 60 degrees, we have 45 degrees. So really this again is just sine of A plus B. And we have a trig identity for that. We know that sine of A plus B is just going to be equal to sine A cos B, sine A cos B, plus cos A sine B. So we can use that here. So let's see what we get when we write this out. So it's sine of A, which is sine 60, cos B, which is cos 45, plus cos A, so it's cos of 60 degrees, 5 degrees. 60 degrees. Well, the sine of 60 degrees is root 3 over 2. The cos of 45 is 1 over root 2. The cos of 60 degrees, is 1 over 2. And the sine of 45 degrees is 1 over root 2. These are all multiplied here and then added here. Okay, so let's see, we can, this here is just 2 root 2, and we've got root 3 on the top. Over here we've got 2 root 2, and we've got 1 on the top. So really that's just common denominator, if you like, is 2 root 2, and then on the top we've got root 3 plus 1. And that's it for sine 105 degrees. Okay, let's try another one. So number 3 here. Let's look at the cos of 240, the cosine of 240 degrees. Okay, so that's going to be equal to, let's see what we can do here. That's going to be the cosine of, I'm thinking 180 degrees. 180 degrees plus, that would be 40, 50, 60 degrees. So 180 plus 60. Now this really again is the cosine of A plus B. So the cos of A plus B we know is, so the cos of A plus B, that's going to be equal to cos A cos B, cos A cos B minus sine A sine B. So we can use this identity here to solve this here. Okay, so we have cos A, which is cos 180, cos B, which is cos 60, minus sine A, which is sine 180 degrees, and then we have finally sine 60 degrees. Okay, so let's work these out. Now the cosine of 180 degrees. So if you remember from your unit circle here, each point here is just cos A sine A for any angle A. So this is 180 degrees here. The coordinates of that there are minus 1, 0. So the first number here is the cos of A. Remember, any point on the unit circle here is cos A sine A for this angle A here. It's a little bit small there, but you get the idea. So this is 180 degrees, so minus 1, in other words, is the cosine of 180 degrees. That's going to be multiplied by the cosine of 60 degrees. The cos of 60 degrees is 1 over 2. And then we have the sine of 180 degrees. Well, you can see here that the second coordinate here is 0. So the sine of 180 degrees is just going to be 0. We've got to multiply that by the sine of 60. The sine of 60 degrees is root 3 over 2. Okay, so we put all this together. Minus 1 times a half is just minus a half. This becomes 0, and that's it. That's really it. So let's see, can I do anything else there? No. Okay, so that's it for number 3. Let's have a look at another one then. Look at number 4 here. Okay, so number 4. Write as sums. Okay, so we have equations that convert sums to products and differences, and sums and differences to products. So the first one I'm going to do is take a product and I'm going to convert it to a sum or a difference, if you like. Excuse me. So this product, trigonometric product I'm going to use is cosine 3 theta multiplied by cosine theta. So let's convert this to a sum. In other words, some trigonometric ratios that are added or subtracted, in other words. So I'm going to write this as a sum. So let's see. We know that, let's see, we need to look down through our trigonometric identities that we have, and we need to look at writing products as sums and differences. So we need to look at that section. And the one that we see, we need to look at something with a cos A, cos B, if you like. So this will be A here, this will be B here, if you like. So 3 theta is A, theta is B. Now the one that we can use is this one here. It's 2 cos A cos B. So here we have a cos A cos B. Here we have a cos something and a cos something multiplied. That's equal to cos A plus B plus cos A minus B. So that's what we're going to use. Now the thing about this is there is no 2 in front of this, so we need to get rid of this. So all you're going to do here really is just divide across by 2. So this is cos B is equal to a half of all of this, cos A plus B plus cos A minus B. Or we can put a half here and a half here. It depends on what way you want to do it. So this is what we're going to use anyway. So let's do it. So this thing here is equal to a half, and then we're going to do cos of A plus B. Well, that's just going to be the cos of 3 theta plus theta, so that's the cos of 4 theta, and then that's going to be plus cos of A minus B, so that's 3 theta minus theta, so that's 2 theta. And you know, that's really it. I mean, you can write it as a half cos 4 theta plus a half cos 2 theta if you like, but remember we started here with this product. It's a cos of something multiplied by the cos of something, and we've converted it into the cos of 4 theta, half cos 4 theta plus half cos 2 theta. Okay, one more then and that'll be it. So we're going to do the opposite. We're going to take, this is number 5 here, we're going to write a sum or a difference as a product. So we have a set of identities that we can use for that. So the one I'm going to do is I'm going to take sine 10, let's say x, 10x plus sine 2x. So this is a sum or a difference. We're adding two of these trigonometric ratios, or we're subtracting them. In this case we happen to be adding them. So we look down along our list of trig identities and see which one will work for us. In other words, we know this is A, we know this here is B, so this is the sine A plus sine B. So look for one with sine A plus sine B. So the one we're going to use here is this one. It's sine A plus sine B, which is exactly what we want, is equal to twice sine of A plus B over 2 cos A plus B, sorry, it's actually A minus B, A minus B over 2. So that's what we're going to use. Now let's start. So here we have 10x is A, this part here is A, and this part here, this 2x is B. So we just slot it into this formula. There's no 2 or anything here that we have to worry about. We have sine A plus sine B here directly, so we just simply write this part of the equation down. So this here is going to be equal to 2 sine A plus B over 2, so it's 10x plus 2x, which is 12x. 12x divided by 2, 6x. Okay, and then we have, oh no, we're not plussing here, this is multiplied by cosine A minus B, so it's the cos of A minus B over 2, so it's 10x minus 2x, which is 8x. 8x divided by 2 is 4x, and that's it. So these two here are exactly the same. Sine 10x, sine of 10x plus sine 2x is equal to 2 sine 6x times cos 4x. And that's it. There are any number of different types of questions you can be asked here, but you just got to look for the trigonometric identity that applies to the particular question and then just do it. Just substitute in the angles.